In this video, we'll use factorial or double factorial to generate the Taylor-Maclaurin series sum of the Fresnel integral cosine. We begin with the formula of the Fresnel integral cosine, which is equal to the summation of a times x to the power 4n plus 1, where a can be a1, which is the factorial, or a2, the double factorial. And the value of n will be from 0 to infinity. In this case, we can go as far as 16, which is good enough. Continue with the double factorial coefficient, which is r the formula, minus 1 raised to the power n divided by. There are three parts or four parts. The first part is 2 double factorial 2n minus 1. So fact double 2 times n minus 1. The second part 2 to the power n. So 2 raised to the power n. And the third part, which is factorial n. So times factorial n. And finally, the fourth part, which is the quantity for n plus 1. So the quantity 4 times n plus 1. We'll correct this. We continue with the factorial. So r the formula, minus 1 raised to the power n divided by, there are two parts, factorial 2n, so factorial 2 times n. The second part, the quantity for n plus 1, so the quantity 4 times n plus 1. Then enter. You'll notice these values are exactly the same, except for the first item. So we correct this. So if if n equals 0, then 1. Otherwise, calculate. Now it's corrected. The two are the same. We continue with the Taylor-Maclaurin series sum. So R the formula, series sum of the x values raised to the power, that is 4n plus 1, where 4n plus 1 starts with 1, incremented by 4n. So 4, 0, 4, 8, 12. So the interval is 4. And the coefficient, you can choose a1 or a2. We begin with the double factorial, a2. And we chart this. Insert chart. And we use scatter chart. The scatter chart will be, and the series show the trend line, polynomial to the 8th degree. For the label, use the equation and the legend position at the bottom. So here's our trend line. We don't need this, we need a space, so we take that out. Here's our trend line and the polynomial of the Fresnel cosine. We continue with we'll calculate this polynomial regression coefficient using Linus. To do that, we complete the Linus matrix. So starting with the power, transpose 0 to 8. And the elements of the Linus matrix will be equal to R the formula of the x values raised to the power 0 to 8. Now we can use Linus. This is equal to Linus dot y and dot x. And let's compare the polynomial regression coefficients. So coefficient of x to the 0 0. Coefficient of x, 0.997. Coefficient of x squared, 0. Coefficient of x cubed, 0.0193. Coefficient of x to the fourth, 0. Coefficient of x to the fifth, negative 0.131. Coefficient of x to the sixth, 0. Coefficient of x to the seventh, 0.0196. Coefficient of x to the eighth, 0. That's because we use the double factorial. Suppose we use the factorial. This is the factorial, a1. We still get the same polynomial regression coefficients, the same polynomial. Yeah, the trend line is still the same, and the data sets are still the same. This completes the use of factorial and double factorial to generate the trend line and trend line polynomials of the Fresnel integral cosine.